Hello and welcome to this 5-minute short on modeling control valves in ADRIAN. So there's two other 5-minute shorts that go with this particular video, and in those what we've been doing is modeling this little fitting here as a control valve, and we've done it in two separate scenarios. One where we've got choked flow through the control valve, so we need to mimic that small area inside that local flow minimum where we get choking across. And then we've also modeled it as a K value, so if we don't get choked flow through the valve, then we just need to act and model it as a fitting loss like all other fittings. So how we're going to build this up into our model. So we have a little model here. If we double click in here, we're going to have 20 bar CO2, so everything that we've been doing before. That's our little control valve, a small network when we're going to atmosphere. If we look inside here, this is our control valve, and what we're going to do is we're going to look at the choked flow situation first. So are we getting choked flow in our control valve? That's the first thing we're going to look at. So we've done our modeling, we've approximated it to a minimum flow diameter of 16.1 square millimeters in that valve, in that fitting. We're going to press calculate. We can open up the results, and as we scroll down here, we can see that's our fitting, that's our control valve. We have choked flow through that valve, so that's going to define the capacity or the flow rate through the entire system. We've got choked flow, so approximating it as a choke with that 16.1 millimeters diameter orifice is all we need to do. We've got a flow rate, we've modeled the system. We can see we've got some subsequent chokes, but that's okay. That's just playing about with the back pressures. We've got the choke. We're kind of like happy. We can then go on with our lives. Now, that's the nice situation. If I drop a little contraction in here, so what we're going to do is going to contract things. It's always good to move these things a little bit just to make sure that they do land and they are connected. I'm going to say that's 0 millimeters. So what I'm going to mimic here is at the very end of my 2-inch pipe, I'm going to put a little 10 mil orifice on. For whatever reason, I'm blowing CO2 into some liquid for some reason, but I've got a little orifice, a little contraction at the end. I'm then going to press calculate. And as we look through our model now, again, this is our control valve here. Actually, what we're seeing is that we haven't got choked flow at that point. The choke is actually coming right at this little end here. The end point, this is where our choking is. So, mimicking this as an orifice isn't really that reliable because it's not behaving in that kind of way. What it really is behaving as is just a fitting like any other fitting. So what we're going to do is we're going to go in here and we're going to get rid of that minimum flow diameter. So we're going to say it's the same as this diameter, but this time we go back to our previous model with our K value, which was around 11.27. So that's how we mimicked the valve itself as a K of 11.27. We're going to press OK. We're going to calculate. And now, again, we still got the choke at the end, but we're actually predicting probably more accurately the pressure drop through that control valve. But we've got a flow rate, and that is how we would do it. So it's a bit of an iterative process. We model the control valves in this choked and non-choked way. We can build the model, run the model first as if you might have choked flow, check for whether you've got choked flow. If you haven't, then go back into that little fitting model, make the diameter the same, but put in the K value, and that will predict the pressure loss through it. And hopefully you've got an answer that you need. Hopefully that makes sense. Until next time, goodbye.